Well, Klaus was supposed to speak today, and I'm pinch hitting for him. And I did get to talk to him. His power was out, and he was able to get a phone to work, and we talked yesterday afternoon. And so I'll try to relay some of his insights and some of his ideas to you also. And I found out about this yesterday late morning, so I guess I'll wait a minute. So let me just talk a little bit. Klaus brought up some interesting things with what's happening right now with the weather in the Front Range. He's been at his site for a little over 20 years, and his summertime daily record was 2.5 inches of precipitation. In the wintertime, he's gotten close to 4 inches of precipitation in a 24-hour period, snow water equivalent. As we were talking yesterday, his highest, within this latest event, he had a 6-inch total for 24 hours. So it really increased things. Guess I'll wait and let you. Very good. So this is why Klaus isn't here. They've had some flooding, as you know. I heard this morning 10 to 15 inches of rainfall in that area. Some locations a little higher, some locations not quite as high. So here is a radar map. It's produced with radar, but then it's also QC'd by people and looking at observations. This is a 24-hour total. And it shows that we have some boulders kind of right in the center there. And it shows that there are some above 8-inch values, 8 to 10-inch values over a 24-hour period, and why they're having such a problem there. What had happened was we experienced some of that moisture here in the beginning of the week. We had moisture plume that was coming up from the southwest, and there was a low pressure sitting out to the west and a high pressure out east of us, and we were getting that nice plume, and we got some moisture here in the Grand Valley. Then that low shifted and and that high shifted over to the east slightly. The low came in, and that plume was shifted to the east and to the Front Range, and it brought their precipitable water values. We send up a balloon every day, twice a day, at stations across the country, and we get different values, temperature values, but also moisture in the column of air. How much moisture do we have there? How much precipitable water do we have? And they broke some of their September records there in Denver with precipitable water, and the result is the rainfall. They also had other contributing factors. They had a cold front. It wasn't real strong, but it was still a front that then added upslope conditions for that. So all that together gave them an extreme event. So, talk about a lot of rain, a lot of precipitation. Now let's go to the other extreme and talk about drought. Are we still in drought? Well, yes, but we have been improving over the summer. I'm going to talk a little bit about the history of the current drought that we've been in, and go through some of the precipitation that we've seen in the past year, talk about the El Nino Southern Oscillation, and some outlooks then for this next season. So this is the current drought map, and it still shows that we are in, we still have some extreme drought in the southwest, and but we have improved, and I'll show that improvements. So let's look at a national level. Always like to get the big picture. I'm going to focus on Colorado a little bit more through the presentation, but it's good to see what our neighbors are, what's happening with them. You can see the latest map is on the right, September 10th, from the U.S. Drought Monitor, and we are showing some improvements here in Colorado and even in Arizona, and some improvement in New Mexico, so south of us, with that monsoonal moisture that we've had over the summer, because the map on the left is from the late spring, just before summer. The one thing to make note of is the west is showing a decrease, or an increase in drought problems, and California, Nevada, and that area, which also gets some of our water, so it's important. So this is our drought map, and then the chart. It may be a little hard to see in the back, but across the top of the chart is our current year, and or the current map as of September 10th, and the numbers show that we are improving, and those are different categories of drought: the D0, the D1, D2, and it gets worse as you go to the right, and it darkens into the red colors. And you can see that our numbers have decreased from over the past few months here, which is good. So let's look at that graphically. I'm going back to March of 2012. It's when this drought was just beginning for us. And the map on the right is our current conditions, so you can always see what our current conditions are. The map on the left will be what we're looking at. It will change. March 6th, 2012, we were just beginning to get into some abnormally dry conditions. The northern part of our western Colorado was moving into a moderate drought. And if you remember, that's when the snow stopped falling about that time, that year, and it dried up, and we were in for a long, warm, dry spring. By May, we're getting into some D2 severe drought has expanded southward and covering all the way into Mesa County from the Wyoming border into Gunnison County and parts of Delta County. By October through the summer, we had it varied as we went, but I didn't want to go through each month. But we went into a large area of severe drought, and most of the western Colorado and the upper basin, Colorado River Basin, were in a severe drought or extreme. By January, start of this year, we were still in drought. We had, and we'll look at the precipitation. We had a fairly good month in December, but it was dry in the fall, and then it started to dry out again in January. We can see that we were still looking pretty bad in the upper basin, with extreme drought over the upper basin by April. And then by June, if you remember, April, thankfully, we started to get some snowstorms that was hitting the central mountains. And the snowstorms brought enough snow and enough moisture to start bringing us out of the extreme drought that we were in, and it boosted us into severe in some areas and actually into getting close to moderate in some areas. Then we had a very dry June, this first part of summer, and the southern areas, mountains and valleys, weren't doing so good. So the southwest started to really increase with the drought, and so it went back up into extreme. And you can also see, and I haven't talked about it much because I'm focusing more on the Colorado River Basin and more of the area that I work in the Grand Junction office, and we cover western Colorado, so I focus a little bit more there. But we're also having a real problem in the southeast part of the state. And then you saw where we are today. So we have improved over the summertime with the monsoonal rains that came, and we've had a fairly good, fairly intense monsoonal season. Monsoon season for us is usually starts around July, first, second week in July, middle of July through the middle of September is the average time that a monsoon, or the monsoonal season is. And not all the events looked like our traditional monsoon moisture. Some of the moisture came from other areas, but that's okay. We won't quibble about that. So this is a very busy pattern, but I wanted to put them all together. I had a coworker say, "Wow, that would make a great quilt." So I don't know. I might have to think about that. I have some quilters in my family. Maybe we'll do that. So what this is monthly precipitation, a percent of average of precipitation. So the reds are below average, and you get into the purples, and that's above average precipitation. And it starts up in the upper left-hand corner with October of last year, and the next over to the right is November, and then December, and then January is the far corner there on the upper right. And then it goes through all the way through the part of the month that we have down in September. So October and November were fairly dry for western Colorado. Matter of fact, all the state looks fairly dry. There were a few spots there in October that had some rains in along the Front Range, but really dry fall. And that led to soil moistures being dry. So, a lot of things it wasn't good coming into the year that way. And then we had a December which brought some snows. As you can see, there were a few areas left out, kind of in the central Gunnison Basin didn't get as much as the north did, or the Four Corners area. And so, but December was a lot better, better than average and closer to average for many areas. So that was good, and we were like, all right, that's looking a little bit better, but we have a big deficit. Remember, the drought started back in March of 2012, so that's a long time, and just 1 month of precipitation usually can't break a drought, although they're wondering about that in Boulder right now. January, it's a little bit misleading. We had some pretty good precipitation in the very first part of the month in the Four Corners area, and so that was looking pretty good, but the rest of the month then trended dry, and you can see in western Colorado the rest of the month from January into February then was mainly below average precipitation. There was a nice swath on the eastern part of Colorado, the other side of the divide, that did get some good snows there in February. March was fairly dry, below average. And then remember April. I talked about April. There's our April precipitation. Fairly nice up in the northern and central parts of the basins. The Yampa Basin received a good amount of precipitation. And that brought us closer to yearly normals. Okay, so we were above average for that month, but we were trying to get to those normals for the year, and it was getting close there. We got close in a few areas. A few stations got above normal for the year after the April, and then the May, which is the center diagram there on the right-hand side. May also had pretty good snows in Summit County in that area, the real upper part of the basin. Then June came, and we dried out in June, and we were well below average, below 50% of average for June. June is usually a drier month around here, but it was really dry. Monsoonal moisture, well, it didn't start until the middle of July. We did have a few events before that. They weren't necessarily true monsoon events, and even the pattern wasn't a typical monsoonal pattern, which you usually have the ridge of high pressure over Texas and that area, and that can allow the plume of moisture to come up over Arizona and New Mexico into Utah and western Colorado. And we didn't have that pattern set up in the early part of July, but we're getting some moisture. The ridge moved over to the top of us in early July, and then it shifted farther up north towards the Pacific Northwest, towards the Intermountain area, Idaho, and allowed some moisture to come in underneath it, and we were able to get a little bit of moisture. So it's been fairly good for us monsoon-wise and precipitation-wise. We have some areas that have had above average precipitation for each of the months for August and then into September here. And you can see September, we really hit some really good plumes of moisture for September. And although that does cause flooding and flash flooding, and it is of a flashy nature that way when you get these strong rains like that. So the Grand Junction office, or right here, in August we had 1.18 inches of rainfall, which is above normal. Normal is about 0.95 inches for the month of August. So we were almost a quarter of an inch over our average for August. And then September, we're already over our average. We're not all the way through September. September's monthly average is 1.19 inches, and we have 1.31 inches as of yesterday. So if it rained a little bit overnight, I haven't counted that. So it was looking good. That's great. But like was said earlier in discussions, it's harder to bank this type of water. But hey, it's water right now, and we were in a drought, so we'll take it. A little larger perspective, and this is from seasonal precipitation. So 2012 water year is on the left, and then 2013 up through August is on the right. And you can see that we have had some improvements in the upper basin, but we are still below average. And this is done a little bit differently than the other maps, how they take different stations and how it's averaged. These are basin averages, so it's done a little bit differently than the other map. But still, you get the same trend is there that we're in a drought. We've been in a drought for a while, but we are improving. We're not there yet. Let's talk about the ENSO, the El Nino Southern Oscillation. The El Nino Southern Oscillation, it's fairly complex, and I'm going to try to simplify it. I need to simplify it for myself. It helps. And so simple definition is a variance from normal sea surface temperatures in the eastern equatorial Pacific Ocean. And that's that blocked area there on the globe, on the image there. And there's a highlighted area there, and we focus on that. The Climate Prediction Center and our office, the National Weather Service, we had to come up with one area that we were going to look at a little more carefully, and they chose that area to kind of simplify some things. And you can use all those areas in combination, and they do look at those. And there's other indices, and Klaus also has an index, a multivariate index that he uses, and I'll talk a little bit about what he's come up on a slide here in a little bit. But I'm going to talk a little bit about what CPC, the Climate Prediction Center, and what they use in predicting and cataloging El Nino, La Nina, and neutral years. So the ENSO cycle, El Nino is a warm change in the sea surface temperatures, and the La Nina is a cold change in those areas. ENSO changes the jet streams, the winds aloft. So the winds aloft change, and I'll show a map of that in a little while, which changes the storm track and results in, we're hoping, predictable effects, but I'll show you what happens in Colorado a little bit with that, which kind of relates to the last talk, because we have a little less predictability here when it comes to these. It's mainly felt in a cold season, so it's a better indicator for cold season than it is warm season. And That's why we use it primarily as a winter outlook tool and not a summer outlook tool. So these are the latest numbers from the Climate Prediction Center. And these are looking at those different, this is the lower diagram on the left-hand side is that same blocked area that was on the globe, okay? And those different areas, so we have the Nino 4, the Nino 3, the Nino 3.4, and the Nino 1+2 areas. And so those are different areas there that we look at. And you can see then the numbers for those, Nino 4, 3.4, and then what the degrees departures are. 0.1 degrees Celsius, 0 for the 3.4, a minus 0.3, and then for the 1 and 2, a minus 9 Celsius. So it's a little bit on the cooler side, that one, but most of them are in more of a neutral pattern right now. A lot of squiggly lines up there. These are model runs. For the different models, there's dynamical models and statistical models, and so this is a spaghetti plot of those. And the one on the left-hand side runs from 2011 through 2013 till now. And the black line there, the dark black line that I've highlighted, is the track that CPC, or the numbers that CPC, and that's Climate Prediction Center, put on what the El Nino number was, or their El Nino number. And so we were in a La Nina in 2011 that changed in the spring of, as we went into 2012, and we started to move upwards. And you can see the models were all pushing upwards. And in the summer of 2012, we were headed towards El Nino. And it was looking that way. And the models were kind of pushing that way. And everything's looking that way. Matter of fact, we were doing some predictions looking at some studies in September for some meetings last year, that we were going to have in October, middle of October. And we were looking at it being an El Nino year. And then what would happen? What would be the effects of an El Nino year? Well, come October, late September, early October, it decided to change on us and go back negative. And so we went back into the neutral. We kind of skimmed across the El Nino, not enough to really call it an El Nino because it wasn't there long enough. You need about 5 of those 3-month time frames to start categorizing it as either an El Nino or La Nina. And we started to come back into the neutral, and we've been neutral ever since. And the models, if you look to the right image, so you can see the red lines. El Nino is above the red line, La Nina is below, and then we have the neutral within the red lines there. And that's a close-up on the right-hand side, and most of the models are staying more neutral. The dynamical models are in that yellow bar that's going up there, and they're trending towards more positive in the neutral or going closer to an El Nino. The statistical models are staying pretty neutral and in the negative, below 0. So let's talk about what happens with El Nino and La Nina. A lot of you know, but it's good to refresh ourselves. El Nino brings a jet stream to the south of us and brings more of a wet environment to the southwest. So north of Colorado is dry and warm. South of Colorado is wet and cool. And it turned out to be a square because of the way I moved my diagram. That's supposed to be Colorado. I know it's not really square, but so that's where Colorado is located. Where are we? Right in the middle. So this is why predicting for Colorado using El Nino and La Nina is a little harder than some areas of the country. We still see some trends, and we try to use that, but it is a little more difficult. So let's look at then La Nina. That forces the jet stream to go up to the north, and we get wet and cool north of Colorado, and a drying and warming to the south of Colorado. And so what does that usually, well, for Colorado, that El Nino means that we get more storm systems that come in from the south, and so our southern mountains, and maybe from the central south, are more favored for precipitation during that year, during an El Nino year, than the northern. Doesn't mean that they're not going to get snow, but it's more favored towards the south. And then for La Nina, it's more, the storms are coming in from the north and northwest, and more likely to come in and clip the northwestern mountains, and so the northern mountains are more favored in the La Nina, and you expect drier conditions in the south. And I can hear some people saying, okay, well that's well and great, but you said something about neutral. We'll get to that in a minute. This is another way of looking at it. We've just done a quick local study of a few sites, mainly ski area and snow recreation sites. But I thought it was nice to add this graph here showing El Nino, more snow falling in the spring and the fall. In the fall and the spring are kind of the better, enhances the snowfall in the fall and the spring with an El Nino event. And then La Nina will enhance the snow more in midwinter for us. Now, remember what we talked about, there's still, with El Nino, it favors the southern, with La Nina, it favors the northern. So this is all of them kind of combined together. So statistics can change things a little bit, but that's, and then on the right side is our neutral years. We've looked at some neutral years. There's about 19 neutral years in there. With the blue line, the average is the dotted black line, and the blue line is the 19 neutral years that we've had since about 1950. And we see a slightly below normal snowfall with that. Now, we decided, well, let's look at the last 15 years or so, see what's happened a little closer. Instead of looking farther out in the paleo, I'm looking a little closer that way, just to see what our trends are in the past 15 years. Well, that's the red line, and it's showing that we're having less, even less precipitation, especially during the middle and the latter part of the season when it comes to neutral years for the last few that we've had. But that's only four, statistically it doesn't mean much because there's only 4 or 5 in there. The interesting thing that we have found is extreme events. We have some of our wettest years have been neutral years, and some of our driest years have been neutral years. You see where I'm going with this? Yeah, I see some people smiling with it. So this makes it even more difficult to predict what may happen. Something we found of interest, and this is this is based on the ONI index, the Ocean Nino index, the one that CPC uses with the 3.4 area and their classification. So this is CPC's classification, and I'm making reference to this is because other indices have indexed them differently, and so their neutral years and La Nina and El Nino years might be slightly different than this. So, but I'm using this as a standard for us since they're part of our organization, and it makes it easy for me. So, since 1950, this is kind of interesting. We've had some neutral years. We've had some neutral years that, like 4 neutral years, 59 through 62, and then going back into El Nino in 63. And we had some combination of neutral years in the early, in the 50s and 60s, and then in the late 70s, early 80s. And then we didn't get those big groups lately. And then even since the 90s, since 1994 on, we've been just one neutral year and then right back into an El Nino. So it's been a little faster. We haven't had those bigger groups that way. So, what does that lead me to believe? The other thing is, what do you see? Do you see a La Nina up there? No. I don't see us transitioning from a neutral to a La Nina, which is interesting with this. So, if I'm going to predict something, I probably would hesitate to predict La Nina looking at the statistics. But it looks like we could either go into a neutral year or an El Nino year. So our outlook is, or CPC, is an ENSO neutral conditions will continue, as you saw those graphs, and they'll continue through the fall and into the early part of 2014. So that's the forecast for a neutral year. So I talked to Klaus yesterday, and so I wanted to give some information from him. And he uses a multivariant ENSO index, and I don't want to get into explaining it that much. I think it'd be better if he did. Too bad he's not here. But with this index, and he feels it's more robust, and it may be, it's a little more complex also. Either continued weak La Nina or ENSO neutral conditions. So you saw that we were in the negative part, and his index shows us a little bit farther in the negative. And so his thinking is that we are going to remain more likely for the remainder of 2013 in more neutral conditions or a very weak La Nina type condition. We talked a little bit more, and it was neutral was kind of what we were thinking instead of El Nino. Well, statistically, that shows that. Well, we looked at that other, so that's good. We're kind of talking the same language here. So now with his index, he's shown that there was one drift into a weak La Nina after a neutral case, and that was back in 1967. But that's using his multivariant index. So. Also, September is a little early for winter season forecast outlook, and locally we have found that too. And last year we really found that out as things shifted real quick on us in late September, early October. We'd like to wait until October to try to get a little feel and work and see how the rest of the summer's going that way. But anyway, there are some trends that we're seeing, and so the trends that Klaus was seeing was for this fall precipitation October through December, and he'll have a better forecast. He was working on some his models, and with this flooding, he was not able to get the computers were not available and things, so he was not able to continue with his modeling. So he said by next week he should have a better idea after it gets it going. So the water has. The abundance of water has affected our drought forecast. Trend is towards near normal conditions at the lower elevations for this period. The trend is slightly less than normal at higher elevations. And I put in there, they're still working on the database. And we're looking at this area October through December because it's fairly important. Rainfall and snow helps with the soil moisture in the early season, and that helps us, I believe, in the runoff in the spring. You go into the winter a little bit better that way. There it changed finally. More on the discussion. He feels we're not likely to see a repeat of the past 2 years. I put that in quotation marks. I'm paraphrasing a little bit, but that's what he was thinking. And he does run a model for leaf area, and this model is trending more positive this year, that's for next year's runoff, than it has the past couple of years. That's good, right? So that's positive thinking here. That's good. The model's kind of leaning more positive that way. What to watch for? If the ENSO system starts to lean towards El Nino early next year, right now the models are kind of showing us staying neutral through that period, although some dynamical models are leaning up towards El Nino, or a very weak one. If we do lean that way, and we'll need to look and watch this as we go into the fall and see how the sea temperatures are doing and see where we are, this would be a good transition. It will generally be better chances of favorable precipitation during the springtime then. So an El Nino transition will favor that February through May precipitation if we trend that way. So something to watch for and see how our trends are and see if we're trending towards those dynamic models. So. And then we talked about some other oscillations, and I didn't have time because that was 5 o'clock by that time yesterday to really get into it and get some slides or to really describe it well. But there are other oscillations out there, and they were alluded to. We have the Pacific Decadal Oscillation, and these oscillations are larger scale than the El Nino. Okay? They're not seasonal, they're more decadal. They're 10, 20-year oscillations. Right now, the Pacific Decadal Oscillation is in negative phase, and the Atlantic Mid-Decadal Oscillation is in positive phase. And this has been in this way since, it started in the late 90s. So the 2000s have been in this, where both of these have been pretty much in that phase that way. And when we've noticed that when these two phases, the PDO being negative and the AMO being positive, that we trend for dry, okay? And that can be seen in the 2000s. So when we look at this, and it looks like these may continue for a few more years down the road, so looking out for the next 5 to 10 years, that would trend to be dry, and we may see more dry years in the next 5 to 10 years, like we've seen the past couple of years, because of this, if we look at this and if we stay in that pattern that way. So the tendency is that it's possible to see more dry years. All right, I'm going to continue with that outlook. Maybe not quite so far out with the 5 and 10 years, but let's look at 5-day precipitation forecasts or outlook. And you can see, and this includes today, because I made the map yesterday, didn't have time to make it this morning, or bring it in this morning. I made the presentation. So this map, this is from the WPC 5-day precipitation, and you can see we're still in a wet regime. They still have quite a bit of moisture plume coming in over New Mexico and into Colorado and western Kansas, and you can see that the big bullseye there for the Front Range too. So that's not so good. So that looks like they'll continue to have showers into the weekend, and so will we. But there'll be more shower thunderstorms. That plume should weaken slightly and not be quite as strong. Oh, I lost my slides on this one. Okay, well this slide here, you'll just have to imagine it. It actually was pretty good. It was telling about how we look at these weather outlooks and the probability. So when you have a equal chance, it's like a dartboard being equal, 3 equal chances there, and you throw a dart at it, you can hit each of those equally. You can hit normal temperatures, you can hit normal or above normal, or you can hit below normal, and you have an equal chance with that. When we get into a 50% probability of above, the normal chances stay the same, but the below average decreases and the above increases. So that's what that was supposed to show. I probably didn't explain it as well as the picture would have. So what do these show? This shows for temperatures in the 6 to 10 day outlook, we have a higher probability of above average temperatures, and we also have a higher probability of above average precipitation over Colorado. And you can look that the line is pretty close to the Colorado-Utah border there. 8 to 14 day outlook. Once again, a higher probability of above average temperatures. And we're on the edge there, but we still have a higher probability of above average precipitation. And that includes like the upper part of the basin. and the mountains, mainly the mountains. So translate that to September, and we have a higher probability. Now this was done in August 31st, this probability, so this map, this outlook. Higher probability of above average temperatures and a higher probability of above average precipitation, which is working out fairly well for us, although I guess now maybe it should have been shifted a little bit farther to the west. These don't pick up those extreme events like what we're seeing in Boulder. So this would be highly unlikely to pick up an extreme event with these type of outlooks. So that's good. That's a good trend that way. So when we get into September, October, November, we have a higher probability above average temperatures in the southwestern part of the state, and then equal chances. The models are kind of saying, well, you have equal chances of either above or below or normal. Now, just to say that, that sounds like, well, we don't know. Well, yeah, maybe we don't, but these are, we've looked at some statistics with these, and there is showing skill levels with these outlooks have increased over the United States. When you look at the whole United States and you look at what they're looking at that way, that the skill level has increased slightly in the past few years. So that's a good thing. October, November, December, higher probability of above average temperatures, and then equal chances again for precipitation. So let's summarize that from CPC. So precipitation, higher probability above normal precipitation for September, equal chances of above or below normal or normal into the fall. And then temperatures, a higher probability of above normal through the fall of temperatures. So I have one more slide. Seasonal outlook, drought outlook from the CPC. We see an improvement across the Front Range. And this was put out in August 15th, and it runs through November 30th. We see a lot of persistence in western Colorado. So I looked at they're now putting out a monthly chart, and I was not able to get that into the program. And they're showing an improvement on the monthly scale, an improvement in western Colorado, which we saw with the drought index, and we saw with the precipitation, and we could see that we were improving. But for the longer term into the fall, they're thinking that the drought is going to persist. Now, it might be less than what we've had before, but we're not going to be totally out of it. I didn't put questions in there, so that means I can sit down, right? So that concludes this portion. Yes, sir.
2002, the graph shows us. Thank you. 2002 graph shows us an El Nino year, yet that was one of our driest years. How did that happen?
Well, once again, if we look at how variable, and I guess I should maybe go back, if I can go back. Maybe I should leave it on that one. No. Okay. Come on. This is slow. Okay. So this is the one that you were referring to. Right. We entered in the fall of 2002, we entered into El Nino, sorry. We entered into El Nino in the fall of 2002. Once again, remember how well we don't correlate with El Nino and La Nina events in Colorado? So just because we have an El Nino or a La Nina doesn't always mean that we're going to follow the traditional pattern. And so, and I'd have to look at that year a little bit more closely. I don't remember off. But so there's a lot of variability here in Colorado, I think is what I'm trying to say. And, you know, we use those patterns, but, and it's not as, but those patterns don't correlate as well as they do for the Pacific Northwest or the southwestern United States and some other areas. We're kind of in that middle zone. So weather sometimes trumps climate. Sorry. But climate is important, definitely. I mean, and it affects weather, but weather sometimes, as we see in the Front Range, weather sometimes trumps climate. So, any other questions?